Hello viewers, welcome to my channel Maths with VTC. Today we are going to see the exercise 2.2 in the second chapter Polynomials. The first problem is find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. You remember the relationship between the zeros and coefficients. Sum of the zeros is equal to minus b by a, where b is the coefficient of x and a is the coefficient of x square. Product of zeros is equal to c by a, where c is constant term and a is coefficient of x square. Now here we are given 6 problems. Let us see one by one. The first problem is x square minus 2x minus 8. So here a is equal to 1, b equal to minus 2, c equal to minus 8. You remember, when you consider the coefficients, along with the sign you have to consider. If there is minus, you have to consider minus sign also. Solution. Let us rewrite this equation x square minus 2x minus 8 as x square minus 2x minus 8 is equal to x square minus 4x plus 2x minus 8. You have to separate the term minus 2x as minus 4x plus 2x. You have to find two numbers so that product is equal to minus 8, sum is equal to minus 2. So minus 4 and 2. These are the numbers. When you multiply, you get minus 8. When you add, you get minus 2. So in such a way, you have to break this term minus 2x. Minus 2x is equal to minus 4x plus 2x. Now you can easily find the zeros of the polynomial. In the first two terms, x is common, take it outside. So x into x minus 4. In this last two terms, 2 is common, take 2 outside, you get x minus 4 common. Now x minus 4 is present in both the terms, you take it outside, you get x minus 4 into x plus 2. Therefore, you can easily guess the zeros. Zeros are x is equal to minus 2 and x equal to 4. These are the two zeros. Now let us verify the relationship between the zeros and coefficients. Sum of the zeros is equal to minus 2 plus 4, which is equal to 2. Which is same as minus coefficient of x divided by coefficient of x square. Actually, coefficient of x is minus 2. Minus coefficient of x is equal to minus 2 divided by 1, which is equal to 2 only. Similarly, product of the zeros is equal to constant term divided by coefficient of x square. Here, constant term is minus 8. So, minus 8 divided by 1, which is equal to minus 8, which is same as the product of zeros. Hence, the result is verified. Now let us consider the second problem. 4s square minus 4s plus 1. Remember, instead of x, the variable is given as s. But that does not change any process. Let us rewrite this equation like this. 4s square minus 2s plus 1. In such a way, you have to separate the middle term. Now it is equal to 2s is common in the first two terms. Therefore, 2s is taken outside. You get 2s into 2s minus 1. Second term minus 1 is common. Take it minus sign outside. You get to minus 2s. You get 2s minus 1, which is equal to 2s minus 1 into 2s minus 1. Therefore, s is equal to 1 by 2 is a repeated 0. S is equal to 1 by 2. Again, s is equal to 1 by 2. For a quadratic polynomial, you get two zeros, but here same 0 is repeated. 0 is 1 by 2. It occurs 2 times. So alpha is equal to 1 by 2. Beta is also 1 by 2. Now let us verify the relationship between the roots and coefficients. Sum of the zeros is equal to half plus half, which is equal to 1, which is equal to minus coefficient of s divided by coefficient of s square, which is minus of minus 4 divided by 4. So obviously, the first result is verified. Product of zeros is equal to 1 by 2 into 1 by 2, which is 1 by 4, which is same as the constant term divided by coefficient of s square. Hence, both the results are verified. Now let us move on to third problem. 6x square minus 3 minus 7x. You look at the problem, the x term is given in the last. So we have to rewrite the given equation in the standard form. That is x square term, x term and then constant term. That is the order. So you rewrite that as 6x square minus 7x minus 3. Again you rewrite the polynomial as 6x square minus 9x plus 2x minus 3, which is equal to 3x into 2x minus 3 plus 2x minus 3. So 2x minus 3 is common. So take it outside. You get 3x plus 1 as a factor. Therefore, you can easily find the zeros of the polynomial. They are x is equal to 3 by 2 and the x is equal to minus 1 by 3. Now you can easily verify the relationship. Find the sum of the zeros. Sum of the zeros is equal to 3 by 2 plus minus 1 by 3. When you cross multiply, you get 7 by 6, which is same as minus of minus 7 divided by 6, which is equal to minus coefficient of x divided by coefficient of x square. Similarly, product of zeros is equal to 3 by 2 into minus 1 by 3, which is equal to minus 3 by 6, which is same as the constant term divided by coefficient of x square. So in this problem also, the relationship is verified. Now let us move on to the fourth sum. 4u square plus 8u. You note that the variable is u and the constant term is missing. That is, constant term is equal to 0. Now, factorization is very simple because only two terms are there. So 4u square plus 8u. Obviously, 4u is common. You take it outside. So you get 4u into u plus 2. So now you can easily find these zeros. 4u is equal to 0 means u equal to 0. U plus 2 equal to 0 means u equal to minus 2. Therefore, the zeros are 0 and minus 2. Now we can verify the relationship between roots and coefficients. Sum of the zeros is equal to 0 plus minus 2, which is equal to minus 2, which is the coefficient of minus coefficient of u divided by coefficient of u square, which is minus 8 divided by 4, which is same as minus 2. Similarly, product of zeros is equal to 0, but here constant term is 0. Therefore, 0 by 4. 0 by anything except 0 is 0. So we get both the results verified. Now let us move on to the fifth problem. Here variable is t. The coefficient of t is equal to 0 because middle term is missing. So b equal to 0, a equal to 1, b equal to 0, c equal to minus 15. This also you can resolve easily. T square minus 15 is equal to t plus root 15 into t minus root 15. I have applied the formula x square minus a square is equal to x minus a into x plus a. Here a is equal to square root of 15. Therefore, you can easily find the zeros of this polynomial, which is t is equal to root 15 and t is equal to minus root 15. The zeros are root 15 and minus root 15. Now we can easily verify the relationship between roots and coefficients. Sum of the zeros is equal to square root of 15 plus minus square root of 15, which is equal to 0. Obviously, coefficient of t is equal to 0. Therefore, 0 by 1, which is equal to 0. First relationship is verified. Second relationship, product of zeros. Root 15 into minus root 15 is equal to minus 15, which is minus 15 by 1, which is same as constant term divided by coefficient of t square. Hence, the relationships are verified. Now let us move on to the last problem. 3x square minus x minus 4. So here a equal to 3, b equal to minus 1, c equal to minus 4. Now we rewrite the given polynomial as 3x square minus 4x plus 3x minus 4. So first two terms x is common, you take it outside, you get x into 3x minus 4. Last two terms you write as such. 3x minus 4 is common, therefore it is 3x minus 4 into x plus 1. Now you can clearly find the zeros of the polynomial, just equate the factor to 0. So you get x is equal to 4 by 3 or x equal to minus 1. Now we can easily verify the relationship between the zeros and coefficients. Sum of zeros is equal to 4 by 3 plus minus 1. When you cross multiply, you get 1 by 3, which is same as minus of minus 1 divided by 3, which is equal to minus coefficient of x divided by coefficient of x square. Product of zeros is equal to 4 by 3 into minus 1, which is minus 4 by 3, which is same as constant term divided by coefficient of x square. I hope it is clear. The result is verified. Now this is second problem of exercise 2.2. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So we have to find a quadratic polynomial. So let us see how. The first problem, 1 by 4 minus 1. Sum of the zeros is equal to 1 by 4. Product of the zeros is equal to minus 1. So let us assume that the required quadratic polynomial be ax square plus bx plus c and zeros be alpha plus beta. So what we are given, alpha plus beta is equal to 1 by 4 and alpha beta is equal to minus 1. But you have taken ax square plus bx plus c as the polynomial. Therefore, sum of the zeros is equal to minus b by a. Product of zeros is equal to c by a. So when you equate these values 1 by 4 and minus 1 respectively to minus b by a and c by a, we get these two relationship involving a, B and C. Now we have to find the values of A, B and C. You can give arbitrary values for either A or B or C. But here, if I take A is equal to 4, these two denominators will get cancelled and I can easily find the value of B. So I take A equal to 4. Then automatically B equal to minus 1 and C equal to minus 4. Now I can write the polynomial. 4x square minus x minus 4 is the required polynomial. In a similar way, we are going to solve the second problem. Now you look at the second sum. The same value we are going to solve. Let the required equation be ax square plus bx plus c and the zeros be alpha and beta. We are given alpha plus beta is equal to square root of 2, which is equal to minus b by a, and alpha beta is equal to 1 by 3, which is equal to c by a. Now we can take a particular value for a in order to solve these equations. So I take a equal to 3. Then b becomes minus 3 into square root of 2 and c is equal to 1. Now easily I can write the polynomial which is equal to 3x square minus 3 root 2x plus 1. Remember, you can give any other value for a. Whatever the coefficients you get, you can write the polynomial. Now third sum. 0 is the sum of zeros and the square root of 5 is the product of zeros. So in the similar way, you take ax square plus bx plus c as the polynomial and alpha beta as 0. Alpha plus beta is equal to 0, which is equal to minus b by a, and alpha beta is equal to square root of 5, which is equal to c by a. So if I take a is equal to 1, then b equal to 0 and c equal to root 5. So simply I can write the equation as x square. Therefore, the required polynomial is x square plus. Now fourth sum, 1 comma 1. So in the same way, you take the required polynomial be ax square plus bx plus c, alpha beta be the roots, alpha plus beta equal to 1, which is equal to minus b by a, alpha beta is equal to 1, which is equal to c by a. So if I take a equal to 1, then b equal to minus 1 and c equal to 1. Therefore, the required quadratic polynomial is x square minus x plus 1. Now we move on to the fifth problem, 1 by 4 comma minus 1 by 4. So same way, you assume ax square plus bx plus c as the polynomial, alpha and beta as zeros. We are given alpha plus beta is equal to 1 by 4, which is equal to minus b by a, and alpha beta is equal to minus 1 by 4, which is equal to c by a equal to 4, then b equal to minus 1 and c equal to minus 1. Therefore, the required quadratic polynomial is 4x square minus x minus 1. Now the last problem, 4 comma 1. Ax square plus bx plus c is the required polynomial. Alpha and beta be zeros. Then alpha plus beta equal to 4, which is equal to minus b by a. Alpha beta is equal to 1, which is equal to c by a. So I take a equal to 1, therefore b equal to minus 4 and c equal to 1. Therefore, the required quadratic polynomial is x square minus 4x plus 1. Thank you viewers for watching my video. Let us meet in the next video class.